All right, hi guys. In the last video, I covered vertical translations of graphs. In this video, I'm going to be covering horizontal translations of graphs. So essentially, that's going to be B and D that wind up affecting your graph. And of course, from B, your period will also be affected. Remember, we're matching to y equals C plus A times your trig function with B times X minus D inside the argument of that trig function. So in the last video, I covered vertical translations. And that's A and C that affect. Okay. I wound up doing this with tangent functions. So for us today, I'm going to stick with that. Our parent graph is going to be y equals tangent x. And then I'm going to have shifted graphs from there. Okay. I'm going to be talking about B and D. Okay, so let's start with B. I'm going to go to Decimus in a minute, but first, it's kind of important before we see what change we have to see how our period is affected by B being changed. So let me go ahead and clear all of this out. Okay, so we're going to start. Let's compare y equals tangent x, our parent, with y equals tangent 2x. Okay, so for y equals tangent 2x, we see that b is equal to 2. And remember, our period is going to be pi over b for tangent graphs. So our period is actually going to be pi over 2. Okay. For your parent, remember b is equal to 1. So your period, pi over b, is going to be pi. So first thing, when b equals 2, parent graph is shrunk horizontally by a factor of 2. Or you can think stretched by a factor of 1/2. Okay, so let's use two tables here. Okay, so before our 5 points for our parent, we should have 0 and pi at the ends. And then we have pi over 2 in the middle. And then pi over 4 and 3 pi over 4. Okay, now our n values should be 0 and pi over 2. And then we have pi over 4 in the middle pi over 8, 3 pi over 8. So remember, you can follow that process of putting, oh, sorry, 1 second. Remember, we actually want to have our asymptotes at the end. This would still work out, but I don't want to do that. Okay. So let me redo my tables. Okay. And then let me actually give another little step here. Remember before, we would put, for tangent, to have our asymptotes at the end, we would put negative pi over 2 to pi over 2, and we would put b times x minus d in the middle. Well, b times x minus d in this case is just going to be x. So I should have negative pi over 2, and pi over 2 is my end values. That way I get asymptotes here. Okay, and then I'm going to have negative pi over 4, 0, and pi over 4. Okay, let's follow this process. For our shifted graph, we still would have negative pi over 2 to pi over 2, but now b times x minus d is going to be 2x. So we have to divide everywhere by 2. We get x in the middle, and we get negative pi over 4, and pi over 4 is the end values. Okay, if you actually find the length of this from negative pi over 4 to pi over 4, that's the period of pi over 2. Similarly, if you were to find the length between negative pi over 2 and pi over 2, that gives the period of pi. All right, so we have 0 in the middle, we have negative pi over 8, and then pi over 8 here. Okay, so when you actually do all your plugging in and stuff, you'll find undefined, undefined, and since we have not affected the range at all, we haven't changed A and we haven't changed C from the parent graph, we actually expect the same values. So we would expect -1, 0, and 1. Okay, and we get a graph that looks something like that for one period. Over here, we would expect same y values, similar shape, just thinner. Thinner than parent, okay? All right, so let's go take a look at this on Decimus. So here's our parent graph, tangent x. We're also gonna put tangent 2x in here. Okay, so you see how before, let's mark some key points here. For the parent, we had an asymptote at negative pi over 2, asymptote at pi over 2. We had negative pi over 4, -1, we have 0, 0, and we had a pi over 4, 1. Okay, now do you see how we've shrunk that piece? This is about half the size, yes? So now we have asymptotes For our second graph, at negative pi over 4 and pi over 4, we still have 0, 0 on the plot, but now we have negative pi over 8, negative 1, and we have pi over 8, positive 1. Okay, so we shrunk our graph down by a factor of 2. Okay, save that. Now, let me clear these values out. And then let's just see how would it change if it's tangent 1/2 x. You can probably tell it's stretching out quite a bit, right? So let's double this. I'm going to go from negative pi to pi. So for this particular graph, I have asymptotes at x equals negative pi and x equals positive pi. I have 0, 0 still on the graph. And then I have negative pi over 2, 1. Sorry, negative 1. And then I have pi over 2, 1. So these are essentially the points. So this is the point on the main parent that gets shifted. If B is 2, you shrink. Okay. If B is 1/2, you stretch. Okay. Note the y value is still 1 here. Y value still negative 1 here. And all 3 graphs have that same position. Okay. Just x moves. All right. Let me save that and clear everything out. Okay, the last thing I want to talk about is phase shift. Okay, so let me clear all this out. So far, A, B, C, and D, we've covered A, we've covered B, we've covered C, so now we've covered D, phase shift. We're going to start with y equals tangent x as our parent. And we will compare y equals tangent x minus pi over 2. Okay, so essentially, let's do this step where we put negative pi over 2 to pi over 2. We're going to put b times x minus d in the middle. We already discussed that for the tangent graph, the parent. Okay, over on this side, negative pi over 2 to pi over 2. We're going to put b times x minus d in the middle. In that case, it's going to be x minus pi over 2. So we're going to add pi over 2 to the middle and to the sides. We've shifted over 0 to 2 pi over 2, which is pi. Okay, note, b is still equal to 1 for both of these. So your period should still be pi, which is perfect. Okay, we get that for both. All right, so let's do our table of values. Come on, man. So x, negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. And then x values for our shifted, we're going to have 0, pi over 2, sorry, pi over 4, pi over 2, 3 pi over 4, and pi. Y values we discussed for tangent, we're going to have undefined at our n values for x, and then we're going to have negative 1, 0, and 1. We get a curve like this. Okay, over here, again, the y values are unaffected. If you are nervous, go ahead and plug these x values in just to check. But essentially, we've shifted these x values to show accordingly where we would get the same y values. So at the ends, undefined. Okay, we're going to get negative 1, 0, and 1. So it's going to look like this. It'll be the same width as parent, but shifted horizontally by pi over 2 units. Okay. And which way did it shift? Okay, so we have d over here as pi over 2. That means our graph shifts pi over 2 units to the right. Okay, so the vertical asymptote that was at negative pi over 2 has now shifted over to 0. Okay, let me save that and then go to Decimus. We're gonna do a tangent of x minus pi over 2. Okay, not the same color. It's practically the same color. There we go. Okay, so for the parent one, see we had asymptotes. At x equals negative pi over 2 and x equals pi over 2. And then here were our special points, negative pi over 4, negative 1, 0, 0, and pi over 4, 1. Okay, now let's go ahead and switch these. Okay, so my parent graph, ooh, no, okay, draw. There we go. My parent graph here, we shifted right by pi over 2. Okay, so that point 0, 0 is now located at pi over 2, 0. Okay, that point pi over 4 1. Another way you can kind of think about this, if I have a pi over 4 for my x value, I'm adding pi over 2 to it. Okay, that's pi over 4 plus 2 pi over 4, 3 pi over 4, which checks out. Now we have 3 pi over 4, 1. And here, this should be pi over 4, negative 1. All right, well, hopefully that helps you guys to understand a little bit better what's happening with the shifting for your graphs in chapter 4. Let me know if you have any questions.